Alright there, sports fans. When it comes down to submitting stuff to Shapeways, there's basically only one way to work, and that's with solids from the beginning. If you really know what you're doing, you can go back and forth between solids and not solids, but I would not recommend it. So let's talk about how to be doing solids from the get-go. Okay, so first of all, what is a solid? You have to think about the fact that even though we're mocking up the 3D environment, we're still in a fundamentally virtual or digital format. It's unreal, so we have to know its rules, even though we feel like we know the rules because they look like our world. So anytime I pull up this menu over here on the left, whether it's a box or a cylinder or any other of these geometric primes, these guys, I believe, without exception, are all producing solids. And the way that I can tell that is if I make a sphere, for example, click the center, click the radius, click the sphere, and then type in what, W-H-A-T, you'll see down here that I have a closed valid surface. Another way you'll see that sometimes is closed valid polysurface. And if it is closed, it is therefore solid. So if I were to send this off to Shapeways, I could get this very expensive and very simple model printed either by filling it with material or having it filled with a sort of honeycomb, right? That'll make it a little lighter and less expensive. So if I start with an object like this, one approach would be to build something out of geometric primes. We just need to make sure that they're linked together. So let's say I come in here through the top and I set up a footprint for a rectangular solid. I'll expand perspective and take a look. I can see that those two have a nice intersection. So now if I come up to my Boolean menu, the first one that I get is Boolean Union. And the prompt says select the surfaces to union, so I pick them both. And watch this little area right here in the middle where they intersect. When I hit enter, I'm going to lose that geometry. And now when I click on this guy, they no longer have interior intersecting geometry. If I type in what, you can see, like I said before, that this is a closed solid polysurface. So now it's no longer a simple prime, but it is still closed, and therefore something that will effectively print over at Shapeways. So let's take another form. Let's say another sphere. And I'm going to be sort of naughty here and work in the perspectival view. You can see it did me a lot of good because that sphere is inside the other sphere entirely. So let's get another clear intersection going. Maybe I'll drag this over a bit. And then we can do another classic kind of Boolean, which is a difference. So with the Boolean difference, you want to start with nothing selected, and then it says select surface or polysurface to subtract from. So the difference is important, the order you pick things in. So this is my thing that will stay behind with a chunk missing. Hit enter. And then this is my thing that I'm using to subtract. It's often easier to click something if you click on one of these black lines that suggests its surface. Okay, hit enter again. And you can see now I've carved away a sort of spherical dent in this object. So it's probably good to get in the habit of continuously typing in what if you're ever unsure and you're verifying that you're a closed solid polysurface throughout. And honestly, Booleans don't work for the most part unless you have two closed solid polysurfaces, because that's how the math operates. If one of these guys is open, so say for example we click this thing and explode it, you can see that now when I type in what, I have a much longer list and I'm looking at a variety of surfaces, but it's not a closed surface. And the reason is that the explosion made all of these surfaces separate, and sure enough, if I delete one, they no longer contain any interior material. So even though I can see this edge, it has no official thickness and therefore can't be printed because it's made up of zero mass effectively. So if I hit undo and I have a whole set of surfaces, as long as every edge is touching a complementing edge and there's no sort of gaps, I can select this whole thing and say join. And then now this thing, if you see down here at the bottom, you might not be able to see in your video, but it says it resolved as one closed polysurface, and I type in what, and I get that confirmation right there. So this whole thing about keeping things closed is going to be crucial for making a print that's going to fly over at Shapeways. Now, another way that you could get this done, you just have to be a little more confident, is instead of starting from solids and working down with Booleans, we could start from 2D forms. Like let's say I grab this interpolate point curve and I make sort of an interesting shape. Right now I have snap turned on. So I might get something like that. click it and type extrude CRV. These should all be familiar from the demo. One of my options is to make this thing solid by default. So if I click here, I get a form that I can't necessarily make if I'm just building it out of simple geometric primes. But if I type in what, I guess here it's saying it is a valid extrusion. But one way to test and make sure that it's working correctly is just to Boolean something with it. So let's do a cylinder, for example. Put it right here, select these two, and pick Boolean Union. And sure enough, the Boolean Union succeeds, and so I can verify, that we're making closed solid poly surfaces. Okay, so these are two different ways of going about this. Starting from geometric primes and cutting them down or adding them together is way number one. Another way is to start from 2D lines and to extrude them into space. You can also mix both of those together, but throughout you should be verifying that things are closed.